Alright, in this video I'm going to be going over part 1 for the motion of a swing. And so what we're going to do is first open Tracker, like so. And once that's opened, we're going to drag our video of the pendulum swing into the window. You can also open it by using this file button and just searching for it. Okay, so here's our motion of the pendulum, which we're going to use to model the person on a swing. Alright, so the first thing we want to do here is to tell it how time works. So we're going to click on this clip settings button. And this video was shot at 240 frames per second, so I'll change this to 240. And so that I don't have to analyze all of these frames, because there are about 500 frames, I'm going to choose a step size of just 10. Okay. And then I am going to track the motion of this thing. In fact, no, first I'm going to just tell it how large the screen is. So I'm going to add a new calibration stick. I'm going to hold down Shift and click at one end of this 20 centimeter ruler and then at the other end of this 20 centimeter ruler. And I'm going to change it to 0.2 meters. Alright, now I've done that, I can right click on it and I can make it invisible because I don't want to have to see that the whole time. And now I'm ready to track the motion of this thing. And what we're going to do with this one is we're going to auto track it. I'm just going to make my screen slightly larger here. And I'm going to remove this side window by clicking this little arrow. I can get that back by clicking the other arrow. Okay, so I'm going to create a point mass. And then I'm going to click on the mass and I'm going to choose auto tracker. So the auto tracker means that we can set it up so that we don't have to manually click each frame. So it says here to shift control click the video feature of interest. So I'm going to hold down control and shift. And I should get this circular crosshair. I had to click on the video screen to get back into it. Okay, and I'm going to find the middle of this thing. And that wasn't quite the middle. I'm going to just skip back a frame so I can fix that a bit. And I'm going to zoom in so I can get it just right. Okay, now I want this circle to be centered here. About there. And I want the circle to include the whole pendulum bob, including just a little bit of the white outline or the lighter colored outline, like so. And then I'm going to move this cross here, which is the point that it's going to mark, right to the middle of that. So now what it'll do in each frame is it'll look for this image here, and then it'll track as its point the very center of that image in each frame. So let's see if that works. I'm going to zoom back out just so I can keep an eye on it, and then click search. And you can see it's going through all the frames, it's finding that image, and it's pinpointing the middle of it each time. Occasionally it has little errors, but it looks like this is working fine. And there we go. It's now tracked the whole motion. Okay, I can now exit out of this. And I'm now going to bring back the little graph window on the side here. You can see here the nice sine-shaped graph for the displacement against time. But you can see that it's not quite at 0. So that's the problem we're going to address now. So we're going to add a set of coordinate axes. And then we are going to just move them so that 0 is in the right place. Now this video starts with the mass at equilibrium, so I'm going to click back to the start, and then I'm going to, just so that I don't screw up my track, I'm going to click this mass and untick visible. You can see my track now disappeared so I don't accidentally move it. And I'm going to move these coordinates, in fact I'll zoom in to 200 and just go down a little bit. And I'm going to click on the origin of these axes and I'm going to bring them right into the middle here. Now that should be the middle of the track as well. So I'm going to make this visible for a moment and I'm pretty much bang on. Okay, so I'll remove that. Now This one little tricky thing here is that we also want the ball, just when we get to looking at energy, we want this bob to reach the same height above the axis on both sides so that we can accurately see the potential energy on each side. So this is fiddly, but I'm going to give it a go. So I'm going to change this graph of displacement against time. You can see that it's now starting at 0 and it completes a full oscillation right about here. And we can check that that is actually the correct 0 point by seeing that it actually goes above the axis the same distance that it goes below the axis. So it goes to positive 9 point something to negative 9 point something. It's not exactly the same, so we're a little bit off, but it's pretty close. Okay, now I'm going to zoom out here to 100%. And what I want to do is angle these axes so that it reaches the same point vertically on both sides. So I'm going to change this to Y position, which is how high it is. And you can see that as we go through here, it goes up, and then as it goes into the negative end, it goes up way further, which means our axes are tilted slightly. In fact, the video wasn't shot perfectly level, so we're going to fix that now. So to fix it, we want to just adjust the angle until these two peaks are the same height. So I'm going to grab this line here, and then I'll move all the way out so I can do really fine tuning. And the slightly annoying thing is the graph doesn't update until I let go of the mouse button, so I'm going to drag it down just a little bit and then check. So now I've angled it too far. Now the first peak is higher than the second peak, so I'm going to go up just a little bit. Okay, that was a little bit too far. I'm going to go down just like a pixel, and now it's pretty much the same. You can see that the two, snooze on that, you can see that these two peaks are now almost the same. If I wanted to go even more fine, I could zoom out even more, and that allows me to do even finer adjustments here. In fact, I don't think I can do a finer adjustment than I had before. So that's about as good as it's going to get. The two peaks are now pretty much the same height, which means that as the pendulum bob swings out, it's going to go up to the same height on this side as it goes on this side, which is what a pendulum should do if the camera was level. So we fixed that now. So that's the calibration of it. Now there are a couple of things that we're going to do in this first section that I'm going to include in this video. And the first one is to obtain a graph of displacement against time. That's simple. We just click on this. I'm going to increase the graph size. I'm going to click on this and change it to X position, which is our displacement. And now we can copy that graph into our report by going to Edit, Copy Image, Plot View, and then pasting it in. Or you can do a screen clipping, which on a PC is just Windows button Shift S, like so. And that gives you a little crosshair so you can take a screen clipping. Or on a Mac, I think it is Command Shift 4, but you could look that up. Okay, so that's the graph, and then your last task is to determine the period of the motion, which you can do by just looking at where this graph crosses 0, like there, and then when you click there, you can look at the time down here, and that will be your period. Okay.